Hello students, today we're doing lesson 10.1 and this is expressing square roots. So we're going to talk, I think we did a little bit of square roots at the beginning of the year, and now we're going to get down to some more detailed with square roots, and we're going to talk about cube roots too, even though the title doesn't say cube roots in this, and we'll talk about what that means in a minute. So let's just go through a super quick first two examples to remind you of what square roots are. So in example 1, it says find the square root of 7 to the nearest tenth. So the first way that you may be asked to find a square root is with your calculator. So this one is using your calculator. So use calculator. And usually when you do the calculator, you're going to put in 7 and then you're going to put in the square root sign. And that should give you something like, it should be 2.6457513. But right here it says nearest tenth. This is the tenth. So your answer would be the square root of 7 is 2.6. Okay, so that's a short, easy, just reminder of what square roots are. And you have a couple of problems on your homework where you do need to use a calculator and find that. So I wanted to go over that first. Okay, example 2, we're going to do kind of the same thing, but not use a calculator. So we're going to estimate. So we don't want to get an exact number. We just want to estimate the square root of 129 to the nearest integer. So integer means a whole number, right? So we're going to not have any decimals here. We just want to know kind of what they really want to know is what's it between. Okay, so even though it says estimate to the nearest integer, they really want to know what it's between. So what I'm looking for is two different numbers or two different squares. So let's try 10 squared. So 10 squared is 100, right? And so that's pretty close, right? So then I would do 11 squared, and 11 squared is 121. So is 129 in between these two? No, it is not. So I didn't pick great numbers there. I'm just kind of showing you. I really do know the answer. So let's go ahead and do 11 squared because I do know that that's still really close to it, 121. And let's do 12 squared. So that's 144. So you see how 129 is in the middle of these two. Okay, it's probably closer to the 129. So that means what the square root of 129 is in between 11. It's greater than 11, and it's less than 12. Okay, so this is kind of like your answer will be for problems like this. Or you could just write it like this. You could say between, this is probably easier for you to write, between 11 and 12. So either one of these is okay to write. Okay? Okay, so now that we've done kind of some just quick remembering how to do these problems, I probably should have given you one that was like super easy, like the square root of 64. So I didn't do one like that because y'all all should know that. That is 8 squared is 64, right? So the square root of 64 is just 8. Okay, so square root is kind of the opposite of squared. You're taking it out of, you're changing the square to be just the number that usually is squared. Okay, so now I want you to see something that we're going to be looking through. Okay, so in your book it just says definition, but it's really just some variables written out. So I'm going to write this out, and then we're going to talk about it with the examples that we're about to do. So if you have x to the a over b, that's an exponent, okay? That equals the b root of x to the a power, okay? So let's look at what this means. This means my bottom number on that fraction is on the outside of the square root, and the top number of the fraction is the exponent inside the square root. So, which it's not always a square root, it's a root. Okay, so let's look back up at this one. If you have a square root, it is implied that it's a 2 right there. So if it's a 2, we don't write it. Kind of like during all of algebra, I've been saying you don't have to write ones, you don't have to write ones. Well, in square roots, you don't have to write the 2. But now we're going to get into some where they're not square roots. They're cube roots and other types of roots. So let's look at example 3. And we're going to go back to this definition. So if you don't understand the definition right now, don't worry about it. We're going to talk about it some more. Okay, so example 3 says simplify the cube root of 8. Okay, so the cube root of 8, when it says cubed root, it's like you're looking for a cube inside of that root sign. So when we did the square root of 64, we were looking for 8 times 8, right? But if we're looking for a cube root, we're looking for, so the cube root of 8, we're looking for something where we can write it 3 times. So that would be 2 times 2 times 2, right? Because 2 times 2 is 4, times the other 2 is 8. You see how I got that 8 that's inside of there? Okay, so another way to write that 2 times 2 times 2, instead of writing all those 2's, is to write 2 to the 3rd power, right? And so now when I find my answer to the cube root of 8, it's just going to be 2. We're looking for that number that we had cubed in there. Okay, so let's look at what that means for what we wrote up here. Okay, so up there we said, I'm going to take this last part right here and I'm going to translate it right here, right? So if the x is the 8, then I would have, I would have 8, and then not 8. We're going to do this one over here because we have exponents on both of these. So I would have 2 to the 3 over 3. So see, I'm using this exponent and this one, just like I did up here. Okay, if that makes sense. So that means that's 2 to the 1st power, which is also 2. Okay, so you could do example 3 without knowing all of that, but we're going to get to some problems where it's a little bit harder to be able to do them without knowing how to do that. Okay, so example 4, we're going to change 3 to the 3rd power. Sorry, it's hard for me to see this. Okay, we're going to change 3 1/3 and x 2/3. I did not write that very well. Okay, so these are both exponents, right? That 1/3 doesn't really look like an exponent. So what that means is when I write my root, the number that's going to go right here should always be your bottom number. Okay, so if those are the same, then that means you can put them in the same root sign. So that's cubed. And then you're just going to put the base down there. And then their exponents inside of there are going to be this top one. Okay, so this would be 3 to the 1 power, but we don't write ones, right? And then this would be x to the 2nd power. So that's how you figure these out. So bottom of the fraction in an exponent goes on the outside, and the top number goes on the inside. Okay, so let's do another one, but the opposite way. So let's do it kind of the other way, where I give you the square root, and you're going to move it over into a numbers with fractions. Okay, so example 5, and let's talk about, sorry, let me erase this real quick, because I want you to know when it's asking you for things in your homework that you know what it's talking about. So this part is called exponential form. And that's easy to remember because there's exponents on each of them. Even though this has an exponent right here, it's not all exponents, right? And then this one is called radical form. So If it asks you to write the radical form, this is what it's asking for. And if it asks you for the exponential form, this is what it's asking for. Okay, so now let's do example 5. So radical form, maybe y'all haven't heard the word radical. That's also a root. Okay, sometimes I'm just calling it a root because it can be a square root. It can be a cube root. It can be a fourth root or a fifth root. So the other name for it is a radical. Okay, so let's go to example 5. And example 5 says, and leave that up there so y'all can see that, to change this to a exponential form. So here's the problem. I write it kind of big. It's the fifth root of 4x to the third, y to the second. Okay, so super easy. If you have this part way up here, this part down in your head, this is super easy. Okay, so I'm going to rewrite that over here on the side just so that I don't have to keep scrolling up and showing y'all. So it said x to the a over b is the same as the b root of x to the a power. Okay, so now let's look at this and let's translate this. Okay, so I'm going to start with the 4, and all the 4 has with it, it doesn't have an exponent on the top, or it doesn't have an exponent here, so we're going to write that as 1. And then the bottom of the exponent is this, right, the fifth. So this is 4 to the 1/5 power. Then let's do the next one, x to the third. So I'm going to have x to the 3 over 5, okay, because this is the top and this is the bottom. And then I'm going to have y to the 2 over 5, because this is the top and this is the bottom. Okay, and that's my answer. So now, before we go on to the very last example, I want y'all to do 2 of these, like example 4 and example 5, on your own. So I'm going to call them 4B and 5B. Okay, so example, let me change my color here. Example 4B, I want you to change 5 and 1/2 and a and 1/2. Okay, change those to a radical. And then for example 5B, so it's this one's going to be just like example 5, is I want you to change the fifth root, or let's make that the fourth root of 3x cubed y. Okay, so hit pause, and I want you, so this one you're changing to exponential form, right? And this one you're changing to radical form. Okay. Okay, so hit pause and do those 2 on your own, and then come back and we'll work them together. Okay, so now that you're back, example 4B should have been really easy for you because they both have the 1s on the top. That means that inside your radical sign is just going to be 5 and a. They don't have exponents because 1s are their exponents, and you don't write 1s as exponents. And then on the outside of the radical form, what goes right here is this bottom number 2. And you can write the 2 there like this. I'm not going to take off points for that. But a square root that doesn't have anything always means it's a 2 on the outside of it. Okay, so that's what you should have wrote was the square root of 5a. So now for 5b, we're going to do the same thing we did right here in green, and that is write them with fractions. So I'm going to go ahead and write all these 3x and y. I'm going to put 3x and y and just leave a little bit of space. So now I need to figure out what the exponents are on all of these. Okay, so for 3, I don't have a top number, right? So that, because this does not have a number here, so I'm going to put a 1. And then my bottom number is going to be the 4. So all of them are going to have the 4 as the bottom number. So x is going to be 3/4. Oops. Sorry, my thing is going crazy. Okay, 3/4. And then y is going to be 1/4 because the exponent here is a 1. Okay, so that should have been your answer. Okay, hopefully you got those two right. If you didn't, look back on it and look at what I did differently here. Okay, and then our last problem is example 6, and I want you to do this one on your own also, because this one is like example 2, so you can look back at example 2. Okay, the cube root of 50. I want to know, what is it between? What two numbers is it between? Okay, now this one's a little bit harder than the one we did a little while ago because it's a cube root. So you're looking for numbers that are cubes, okay? So see if you can do it on your own. If you're not really sure, you maybe get out your calculator and try a few things, but then come back and we'll work it together. Okay, so now that you're back, let's talk about some of the cubes. Let's go ahead, because cubes are harder to do in your head. You don't see them all the time like you do with squares. Let's talk about some cubes. So 2 cubed would be 8, right? Because it's 2 times 2 times 2. That's not 6. 2 times 2 times 2 is 8. So now let's talk about 3 cubed. Well, 3 cubed, I can do 2 cubed is 8 really easy in my head. Let's talk about 3 times 3 times 3. So that's going to be 9. Then I have times another 3. So, hold on, my equal sign looked like a Z. 3 cubed is 27. Okay, and then let's go to the next one, 4 cubed, because we haven't gotten close to 50. Remember, I'm trying to get close to 50. So let's look at 4 cubed. 4 cubed means 4 times 4 times 4 times 4. So 4 times 4 is 16. And another 4 times 4 is 16. So that's 64. Okay, I got closer to 50, right? So it's between these two, which means the cube root of it is between 3 and 4. Okay, because that's the numbers that are here. Okay, so that's your answer for example 6. So be careful on the ones where it's asking you to do things in between. Look at whether it's a square root or a cube root, because that could get you the wrong answer. Okay, that's it for today. Oops. Trying to turn this off.